Hi, in this video I'm going to discuss what is Cayley-Hamilton theorem, and the utilization of this theorem is that it's very easy to find inverse of a given matrix. Suppose in normal inverse that you people have done in your higher secondary, you have to find the adjoint, you have to find the mod of that matrix as determinant, and then you are going to find their the ratio, excuse me, sorry for this, the ratio, and then you are going to find the inverse, right? It is adjoint of a divided by mod of a, that is inverse. So here Cayley-Hamilton theorem makes it easy to find the inverse of a matrix. So let's see what's the statement of Cayley-Hamilton theorem and the utilization of it. Okay, the theorem says every squared matrix satisfies I'm going to the next page. Okay, please write it down. Every square matrix satisfies its own characteristic characteristic equation. This is Cayley-Hamilton theorem. This is the statement that every square matrix satisfies its characteristic equation. So let's do an example and let me clarify the concept. Okay, so let's do it. Suppose I have a matrix A, three-dimensional, and if it is two-dimensional, use your conventional method. Okay, that will be easy. Adjoint is just a one-step process. I have discussed that in my previous video. That right hand, left hand shortcut. Go through it, and finding determinant is also a one-step process. Whatever. So let me take a matrix and write the characteristic equation of that matrix. The matrix will satisfy that equation. We don't need to prove Cayley-Hamilton theorem. Just this is statement. For competitive exam, we people don't need any proof. Yes, for interview purpose, they don't ask obviously this type of mathematical physics proof. So it's up to you. Okay, I'm not doing that. If you want, I can, but I'm not interested. Whatever. So okay, yeah. So A is equal to 4 3 1 2 1 minus 2 1 2 1. Okay, so what we need to find? This one, lambda cube, the characteristic equation. Lambda square plus stress plus lambda sum of determinants, all possible determinants, minus the exact determinant of the given matrix. We people need to find this, right? So let's do that. Let's find determinant first. What is the short trick? 4 2 1 3 1 2 1 minus 2 1. Again 4 2 1 3 1 2. Okay, that reflection angle of incidence concept, this one minute, yeah. This line, this will make you the to find the S1, and this one, this one, this one. This will make you find S2, right? So S1 is, let us calculate, 4 into 1 into 1 is 4, plus this is minus 6, 3 into minus 2 into 1, and minus 2 into 2 into 1 is minus 4, so we get minus 6. Sorry, 4 4 8 8. No, this is somewhere I have done any mistake or what. Oh, here is 2, right? Sorry, here is 2, so we just repeat these 2 rows, sorry, 2 columns, and here we just repeat the 2 columns. Okay, these 2 columns we need to copy and paste. So yeah, S1 is equal to 4 minus 6 plus 4, which is equals to 2. Okay, and here we get 1 1 1. Here we get, it's a huge number, 4 into 2 into 2, we have a minus 4 into 2 8 8 into 16, minus 16. So 1 minus 16 is minus 15, minus 15 plus 6 from here is minus 9, right? So S2 is minus 9. You can do the calculation of your own, it's not a big deal, it's becoming very hazy, so never mind. So S1 is equal to 2. So understand what is the, just let me recapitulate. This is the matrix. We just repeat the first 2 columns, just multiply this line, this line, this line, and add within them. Same for the left hand side, and we just do this. Okay, yeah. So our determinant is, where is the pen? Oh, my screen is not working, I don't know why. Okay, now it's working. Something happened, I think. Can I pause the video? No. Okay, sorry for the interruption, I don't know what had happened. Whatever. Okay, so it is S1 minus S2, which is equal to this was minus 9, right, from the previous page. Yeah, it was minus 9 actually. It's very easy, I'm extremely sorry. Minus 9, so it will be plus 9 equals to 11. Okay, if you have gone through my previous video, you know how to do this. Please go and watch my video, that how to find the determinant in a shortcut way for IIT Jam physics on table. You will get. Okay, I know you are following my channel. Whatever. So determinant is 11. Now let's find the determinant, that sum of all the possible determinants for that lambda. So first one we have, what was our, let me use this page. Okay, this one, and this one. I need this, so it's 4 3 2 1, 4 3 2 1 plus, what is this, 1 minus 2 2 1, 1 minus 2 2 1, and last one is 4 1 1 1, correct? 4 1 1 1. Let us check what will be the result. 4 into 1 is 4, minus 6 is minus 2. Yeah, 1 into 1 is 1. You understand this? 4 into 1 minus 3 into 2. Okay, okay, you know this. 1 into 1 and minus is 5. This one is 5 and this one is 3, right? Yes, 4 minus 1 is 3. So it's 8 minus 2 equalizes 6. So 6 is going to be the term. Okay. So let's do black and white contrast. White, my favorite one. So now we need to find the trace of the matrix. What is the trace? This is 4, this is 1, this is 1. 4 plus 1 plus 1 is equal to 6. So trace equalizes 6. So what is our, अब मैं क्या करूँ? ठीक है, lambda cube minus lambda square trace plus lambda sum of what I say among determinants or all possible determinants minus the determinant. This is no official name. This is the name given by me. You can use another name as per your convenience. Okay, so trace is equal to, okay, lambda, okay, delta is 11, right? Trace we get 4 plus 1 plus 1 equalizes 6. And what is this sum we get? Also we get 6. That sum is equal to 6. So it's very easy. So first lambda cube minus lambda square trace plus lambda sum amount, which is equal to 6 again. You remember the sign convention? Opposite sign will be there. And 11 is the determinant of the matrix, equalizes 0. So every square matrix satisfies its own characteristic equation, means that the value of A, that is the matrix, will satisfy this equation. Okay, this is Cayley-Hamilton theorem. That is, A is given as the matrix, this A will replace the lambda, that is that the matrix satisfies this equation. Okay, this is the funda. So A cube, and this is a square matrix, symmetric, you see, minus lambda square, which is A square. Nothing, it's just same as the value of x in a cubic equation. We have a value 1 as the solution of the equation. If you put 1, it will satisfy that equation. Same here, lambda is the solution. Suppose, okay, just A replaces the lambda and nothing else. This is the theorem. Okay, I'm just using the theorem. I'm not giving you the official proof of the theorem, but I'm just giving you the theorem. So lambda square into 6 plus A6, oh my god, okay, minus 11. So what I told, we'll find inverse of a matrix in a very easy process from this theorem. So A cube minus 6A square plus 6A minus 11 equalizes 0. So every square matrix satisfies its own characteristic equation. By following Cayley-Hamilton theorem, we derived up to this. So from this we are going to find how you can find the inverse of the given matrix. Okay, so I am using the next page again. A cube minus 6A square plus 6A minus 11. Let us divide a in both the sides. If we can do that, it will imply a square 6a plus 6 minus a inverse 11 equalizes 0. You get my point? Just a division with a on both the sides. Okay. By is the correct preposition. I'm weak in preposition from my childhood. Whatever. By is the correct division by 11. Whatever. So a square minus 6a plus 6 minus 11 inverse equalizes 0. So what is the answer then? Very easy. We'll take this 11 on this side and just put this 11 under division sign. We'll get the answer. This is the answer then. This one. Okay, let me do a square minus 6a plus. Okay, let me tell you one thing which is very important, because this is a matrix representation. When you just divide this a by a, you will get an identity matrix, because this is a matrix representation. A is a matrix, no? So you know that if you multiply I with something, it is equal actually 1 in what is 1 in general case. I told in my previous videos what is 1 in general case. Identity matrix is similar in uh, matrix cases. Okay, so minus 6a plus 6i is equal to 11 square, sorry, a inverse. So what's the value of a inverse? 11 will come in this side, so a inverse is equal to a square minus 6a plus 6i divided by 11. So this is the value of a inverse. Now from competitive point of view, I am keeping this video up to this because in examination you people just need this concept. Yes, for three-dimensional inverse, now you people need to find the square of this, that is a given a and identity matrix, and then divide them by 11. I hope you can do this, and you can comment it below that what answer you are getting, just as an exercise. You can do this, but for competitive exam like jam, up to this it's more than enough. Okay, just remember this form, that was the approach. Okay, so nothing, a matrix will be given. What is the matrix, man? Yeah, a matrix here. This matrix, a very easy matrix. Yeah, this matrix will be given. What people need to do is that just find the characteristic equation, that lambda cube form, this form, put the values, satisfy a in this equation. Okay, satisfy this a in this equation, equalizes 0, find the inverse by dividing a, and don't ever forget to put identity matrix, because this is in matrix form. You'll get 0 after doing this lot of efforts. So yeah, I'm keeping this video after this, and please comment it down what result you people are getting. Okay, thanks for watching the video.